It says we have a 60-kilogram paratrooper leaps from a plane. Her parachute fails to open, but luckily she lands in a snowdrift. She hits the snowdrift with a velocity of 75 meters per second and comes to a stop within 0.8 seconds with only a few broken bones. What was the net force exerted on her by the snowdrift? So with these problems now, it's very important that we write everything down and that we get our labels and subscripts correct. Okay, because they're going to start to begin to give you a lot of information, and it's very important that we put the things in their proper places. So first we know that she has a mass of 60 kilograms. It then says that she hits with a speed of 75 meters per second. So her initial speed is going to be 75 meters per second. Now what's her final speed when she hits the snow? Yeah, it's 0. Good. So her final speed is 0 meters per second. And it says it takes her 0.8 seconds to stop when she initially hits the snow. And they would like to know what force is exerted on her to cause her to stop. Okay. So looking at this information where I've got mass, I've got speed, then I have a force and time, really the thing that kind of gives me an indicator as to what I should start to look at is impulse, because I have force and time. All right, whenever there's force being mentioned, we want to start looking at impulse because that's where the force is located, is in impulse. Okay. So, like we've talked about the past couple days, impulse is a change in momentum. Remember that J is impulse, P is momentum, and this triangle is a delta, which is the change. All right, it's final minus the initial. So we know that impulse, helps if I write a T. We know that impulse is force times time. Okay. So we know that impulse is force times time, and change in momentum means mass times velocity, the final velocity minus mass times the initial velocity, because momentum is mass times the velocity. And delta means it's the change in it, the difference between the two. All right, so now it's just a matter of plugging in what we have. So we need to find F. We know that T is 0.8 seconds. She's got a mass of 60, a final speed of 0, right? Another M is 60, and then her initial speed is 75. Okay. So we get 0.8 F equals negative, I believe 60 times 75 is 4,500. Anybody have a calculator? Want to confirm that? It is? Yeah? Oh, I thought you were confirming for me. Yeah? Okay, so 4,500. So then if we divide by 0.8, we get that F is negative 5,625 newtons. Okay. Now, this negative sign, right, the negative 5,625, that should be negative. Right? If you think about it, she's falling, but she's slowing down, right? She hits the ground and she slows down when she comes in contact with the snow. So this negative sign tells us that it's acting in the direction opposite of what she's traveling. Okay, does that make sense? Right, so if you have a force that's acting in the direction opposite of you, that means you slow down. Okay? If we got a positive sign, that meant that she hit the ground and she went faster. Weird. Okay? So, makes sense? Not too terrible? Okay, are there any questions on this one? Good? All right.